Okay, so today in this handout, we're going to talk about a system of nonlinear equations. It's a system where at least one of the equation is not linear. Linear means that the exponent of your variable, they're all one. And if it's nonlinear, you're gonna have higher degrees like 2, 3, 4 as the exponents of the variable. But today we will just focus on the first and the second degree equations only. All right, and then we will talk about a few methods to solve these systems. You could look at the section title here. The first method is called the graphing method. You basically graph those two equations and then see where they intersect. The intersecting point is the solution, and sometimes they might intersect at multiple locations. For the second method, we will use substitution method, which is very similar to what we did for the linear system. Same thing with the third method, which is called the elimination method. And at the end, we will have a word problem, which summarizes how you use nonlinear systems to solve word problems. Okay, so that's the intro, and we're going to start with the first method, graphing method. The graphing method requires you to graph the two equations. So let's look at these two equations. The first equation is x minus y equals -2. This will be a linear equation, which means the graph will be a line. All right, so if we graph this, we know it's going to be a line. And to graph a line, 2 points determine a line. So let's actually graph the line. And you know me, I'm going to do a XY table just to get 2 points. And the best way to do it is using the diagonal zeros. So I'm going to make x 0, and then you can kind of plug in. So this one is 0, so that just means this one goes away. Your equation is just -y equals -2, so that means y is 2. And let's put that right here, y is 2. And then second one, y is 0. So y is 0, which means this one is 0 and this one goes away. Your equation becomes x is -2. Let's write that down. Okay, so we have these 2 points. Let's mark these 2 points. I'm going to use green. So we have 0, 2, which is right here. And then we have -2, 0, which is right here. 2 points determine a line, so we have our line. All right, so we have our line. And then next, we're going to graph the second equation. The second equation is y equals x squared. This one is a quadratic equation, so you know the graph of a quadratic equation is parabola. And it's a vertical parabola, so it's either going to be a happy face or a sad face. Since the coefficient of x squared is positive, we're going to have a happy face. And how do you graph a parabola, right? Same thing, we're going to need a few points. So you could definitely start with the axis of symmetry or the vertex and start from there. Or you can do what I'm about to do. I'm going to do an XY table. And then I'm definitely going to start with 0 as before. So if my x is 0, then this part will be 0. So it's basically gone. And that means the y is also 0. And then since this one is y equals x squared, I could make a few points by doing plus minus. So I could make x equals 1 and -1. And when you square this value, your y is also 1. If I make my x plus -2, meaning +2 or -2, I square my x, I will get 4. So you see where I'm going, right? I'm just picking up opposite values of x and then plug into the equation, solve for y. Because of the symmetry, these 2 points will be symmetric about the axis of symmetry. And let's just do 2 more points, plus -3, then y will be 9. So we have 7 points right here. Let's plot these 7 points. I'm going to use pink. Start with 0, 0. So put 0, 0 right here. And then 1, 1, right? -1, 1. And you already see there's the intersection right there. And then we have 2, 4. 2, 4. That's another intersection. and then negative 2, 4. And then we have positive 3 and 9. So that will be all the way to the top. And then negative 3, 9. Okay? And then once we plot these points, you could kind of see the pattern, right? Make sure you connect them with a smooth curve, not a line. I'm just trying my best. Make sure that it's a smooth curve. All right, so I have my parabola in pink and my line in green. Let's highlight the point of intersection. So we have this point and we have this point. Actually, let's change the color. It's kind of hard to see. Okay, so these two are the points of intersection. Let's mark the coordinates. This one is 2, 4. And this one is negative 1, 1. And as you can see, we have 2 points of intersection. Those two are the solution. And that's example 1. Practice 1 says, sketch and discover the cases in which a parabola and a line can intersect. For each case, state the number of solutions. So I'm going to give you some time to think about this. You could do some sketches yourself and see how they can interact. Apparently, we have one case, which is on the left-hand side, right? In this case, there are 2 points of intersections. Can you come up with other cases? Okay, hopefully you did that. So I'm going to do the third case first, right? The third case is you have a parabola and then you have a line, and there are 2 solutions, just like the one on the left. And then some of you might say there could be just one point of intersection. For example, my line could be like this. It just intersects at one point. Then number solution is 1, right? So those are all lines. And then there's also one case where you have a parabola and you have a line that does not intersect at all. In this case, 0. So we have these 3 different cases. You can find similar cases if your parabola opens downwards, but it's basically the same thing. All right, that's practice 1. Let's move on to example 2. Solve the system by graphing. So again, we're going to graph these 2 equations. The first one, x equals negative 6. This one is a vertical line. As you can see, there is no y in the equation. So how do you graph this? You just find out negative 6 on the x-axis, which is right here. Right here, right? That's negative 6. And then you just graph a vertical line. Let's graph a vertical line. Okay, so that will be the first equation. Second equation, we just talked about the equation of circle. This is a circle. And before you graph, you should find 2 things, right? For this circle, you need to find center and radius. Radius is usually the easiest one to find. On the right-hand side, r squared is 9. So you know r is 3. R radius is 3. And then for the center, you just look at these 2 numbers. These 2 numbers. You just write the opposite of these 2 numbers. So the first number is positive 3. That means we're going to have negative 3 as the x coordinate. And then second number is negative 1. You write the opposite, which is positive 1. So our center is negative 3, 1. And now let's mark this center. Negative 3, 1. So it's right here. That's the center. And last time I did talk about how you graph a circle. You basically go to the top, bottom, left, and right based on the radius, and then mark those 4 points, connect them with the smooth curve. So I'm going to go up. Since the radius is 3, so you start with the center, you go up 3 times, we get our first point. And then you could go down, get your second point, go to the left, third point, go to the right, the last point. All right, and then you connect them with the smooth curve. Okay, and now we have our circle and we also have our line. The point of intersection is pretty obvious, which is right here. The coordinates is -6 and 1. And that's our solution. So there's only one point of intersection, meaning that this system has just one solution. Practice 2 says you're going to sketch and discover the cases in which a circle and a line can intersect. For each case, you're going to state the number of solutions. And we have one case where we have a circle and we have a line, right? And there's just one point of intersection, so the number solution is 1. Can you come up with other cases? So I'm gonna give you some time, think about this. Okay, so it's gonna be very similar to practice 1, right? You could have a circle, and then you could have a line that just doesn't cross the circle at all. In this case, 0 solutions. You can also have a circle, and then you have a line that crosses the circle, where the 2 points of intersection, there are 2 points of intersections. Okay, so that would be 2 solutions. And that's the first page. It's the first method to solve a nonlinear system of equations. Moving on to second page, substitution method. Substitution method requires you to solve one of the variables, and usually that variable comes from the lower degree equation, meaning the linear equation. Usually that's what we look at. For example, example 3, if you look at these 2 equations, the first one is nonlinear because we have 2, right, at the exponent. And then for the second one, this is linear because we have 1 and 1. That's the linear. As a result, you're going to use the substitution method, substitute the second equation into the first one. The second equation is an equation of y, meaning that in the first equation, when we rewrite this, we're going to replace the y with the second equation. And in this case, it's x plus 2. So we're going to raise this to the second power. That's the y squared equals 4. So this will be what happens after you substitute. We get a quadratic equation. Before we solve this, I do want to discuss the graph of these 2 equations. The second equation, it's a line. That's pretty obvious. The first one is an ellipse. We did not talk about different kinds of graph, but this is one type of the section graph, conic section graph. So if you look at the textbook, there are more detailed discussions about ellipse and other kind of graphs. All right, let's solve this equation. To solve this equation, we're going to expand this parentheses. I'm going to use formula. You could do FOIL or the box method. Equals 4. All right. And then I noticed that there are 4 on both sides of the equation, so I can cross them out. It's equivalent to subtract 4 from both sides. And I'm going to combine like terms on the left-hand side. 4x squared plus x squared, that's 5x squared, plus 4x equals 0. And this equation is best solved by factoring. I'm going to take out a GCF. There is a GCF right here, which is x. You take out x, and then you will have 5x plus 4 equals 0. This is a 0 product. By the 0 product property, each of them could be 0. So your x could be 0. Your 5x plus 4 could be 0. For the first one, it's already solved, so we don't need to do anything. For the second one, if we solve for x, you will get x is -4 over 5. And for the system, we still need to solve for y. To solve for y, you just plug these 2 solutions of x into any of the original 2 equations. And I'm going to say equation 2 is probably the best. This is because equation 2 is an equation of y. So I'm going to plug the value of x into equation 2, saying that y is x plus 2. So in this case, it would be 0 plus 2, which is 2. And that's our one solution, 0, 2, right there. For the second solution, I'm going to do the same thing. Y equals x plus 2. So that's negative 4 over 5 plus 2. I'm going to rewrite 2 as 10 over 5. 10 over 5 is 2. And this will give me positive 6 over 5. So I have my second solution, negative 4 over 5, and then positive 6 over 5. We have two solutions right here. And notice that this system has solutions that are not integers. If you don't have integer solutions and you solve by graphing, it's going to be very difficult, especially if you're doing it by hand. So that's why substitution method is probably the best. The practice one, I'm going to let you guys practice. But before we start giving you the solutions, I do want to talk about the graph of these two equations. The first graph, y equals 4, it's a line. And the second one, this is a circle, right? So go ahead and solve this. And once you solve this, check if your solution is correct. The solution to this one, I'm going to write it down. It's 2 plus radical 3 comma 4. And the other one is 2 minus radical 3 comma 4. So you have two solutions. Elimination method. Elimination method will require you to choose one variable to eliminate. And preferably, they should have opposite coefficients. And then you simply add the two equations. When you eliminate, just make sure that the variables are exactly, the variable parts are exactly the same. So for example, example 1 here, we have x squared and x squared. They're definitely alike, right? They're definitely alike. But for the y's, they're different. One is y squared, the other one is y. And that made our elimination process much easier, which means we have to eliminate x squared. We have to eliminate x squared. Make them opposite coefficients. So apparently, right now, they are the same, the coefficients. So what we need to do is we need to modify one of them. How about we multiply the second equation by -1, right? I multiply the second one by -1. If I do that, my x squared will become negative x squared, which will allow me to eliminate by adding it to the first equation. Copy the first equation, and then multiply the second equation by -1. You will get negative x squared positive y equals -4. And then we can add them. So let's add these two equations. When you add these two equations, since the coefficients of x squared are opposite numbers, they cancel out. On the left-hand side, we have y squared plus y. On the right-hand side, we have 4 minus 4, which is 0. Perfect. So this equation is best solved by factoring. There is a GCF, which is y. We take out y. We get y plus 1 equals 0. By the zero product property, each of the factors could be 0. So we write two equations, y equals 0, y plus 1 equals 0. The second equation solve, you will get y is -1. And then we're going to solve for x. So this time, we don't have a linear term for x. All we have is the square part. So I'm going to name my equation. Let's say this is my equation 3. This is my equation 4. To solve for x, we need to do some substitutions. I'm going to write it right here. So I'm going to choose equation 2. Because equation 2, the y is a first degree term, which is easier to deal with. If I plug in y equals 0 into equation 2, I will get x squared minus 0 equals 4. And that simplifies to x squared is 4. So x is, apply the square root property, plus minus square root of 4, which is 2. So we have our first pair of solutions, plus minus 2, comma 0. Since I used plus minus, there are 2 points right here, 2 comma 0 and -2 comma 0. Or you could just put them together with the plus minus sign. And that would be the first pair of solution. I use the word first pair because we have another value for y, right? So equation 4, we're going to do the same thing. Substitute 4 into equation 2. So we have x squared minus y. Our y is -1, so minus -1 becomes plus 1 equals 4. Subtract 1 from both sides. X squared is 3. And then we apply the square root property. X is plus minus square root of 3. So we have our second pair of solution. Plus minus square root of 3, comma -1. So that would be the second pair of solutions. In total, we have 4 solutions. So what are the graphs of these two equations, right? The first one is a circle where the center is 0, 0. But the second one is a parabola. So notice that the y and the x squared. And you could look at the textbook and see all the different cases where a circle and a parabola can intersect. If you're curious, there are 5 different cases. So you could actually sketch it out yourself. All right, moving on to practice 4. Practice 4, I'm going to let you practice yourself, but I will tell you the graphs. The first equation, it's a circle, and the second equation is a hyperbola. All right, and then, the hyperbola looks like this. Looks like this. And again, there are different cases where a circle and a hyperbola can intersect. There are a total of 5 different cases. So if you're interested, you could either look at the textbook or you could sketch yourself. I'm going to give you the solution to this system. There are going to be 4 solutions again. So we have 2 radical 3, 2 negative radical 3, and then -2 radical 3, and then -2 negative radical 3. So a total of 4 solutions. Okay, practice 5. Mira purchased a small 25-inch TV for her kitchen. The size of a TV is measured on the diagonal of the screen. The screen also has an area of 300 square inches. What are the length and width of the TV screen? It's about a TV screen, so let's actually graph a TV screen, right? Most of the TV screens are like this. It's 25 inches, and you should know that that 25 is talking about the diagonal. So let's label our diagonal with 25. The area is 300 square inches. And then we also have our length and our width. So I'm going to measure that. I'm going to assume that the length is greater than width. Okay. So I'm going to assume length is greater than width. But it is also possible that length could be less than width. But for this one, just for the simplicity, we're going to assume the length is greater than the width. And then we're going to create our equations. Since we have 2 variables, we need 2 equations. The first equation, you could use the diagonal, right? The diagonal is 25. And we also notice that there's this right triangle right here, which means we can use the Pythagorean theorem. Using the Pythagorean theorem, we have the length squared plus the width squared equals 25 squared. So that would be the first equation using the Pythagorean theorem. The second equation comes from the area of this TV. It's a rectangle. The area is length times width, and that is 300. Okay, so we have these 2 equations. Let's label them 1 and 2. Once you have the system, the rest of the problem solving is simply solving this equation. So I'm going to use substitution method. This one, elimination is not that good. Substitution is definitely the way to go. I'm going to choose equation 2. Solve equation 2 for one of the variables. Let's solve for L. All right, so solve for L, I'm going to divide both sides by W. So L is 300 over W. And I'm going to name this equation 3. Once you have equation 3, you could do the substitution. So I'm going to substitute 3 into the equation that we did not use. We used equation 2, we did not use equation 1. So you're going to substitute this into equation 1. Replace L with this. So we have 300 over W squared, right? That's L squared, plus W squared equals 25 squared. Let's calculate that. 25 squared is 625. And this is the equation in W. Let's simplify this. We're going to have 90,000 over W squared plus W squared equals 625. So how do you solve this equation, right? Our variable is in the denominator. The best way to solve this is by multiplying everything by the LCD, or the denominator that we have right here, which is W squared. So I'm going to multiply everything by W squared. And this will give you, so for the first part, the denominator and the W squared will cancel out. It's just going to be 90,000 plus the second product, you're multiplying W squared by W squared, so that's W to the 4th equals 625 W squared. Okay, and then we're going to reorganize this equation. The highest term is 4th degree, and it's positive on the left-hand side. So I'm going to move this to the left-hand side. Subtract 625 W squared from both sides. We have W to the 4th degree. Subtract 625 W squared plus 90,000 equals 0. This is definitely a much harder equation to solve because it's not a quadratic equation, but it is a quadratic equation in disguise. You are able to factor this. Let's rewrite the W a little bit. It looks a little weird. So you are able to factor this. If you factor this for the W to the 4th, you just have to think that W squared times W squared is W to the 4th. Right, so it's the same way to factor this. W squared times W squared gives you W to the 4th. And then for the 90,000, you're going to come up with two numbers such that when you multiply, you get 90,000. Since the middle term is negative, we know that both of the two numbers must be negative. And if you're curious, you could pause this video and think about which two numbers will work. And then restart the video, see if the numbers that you select are right. Okay, so the two numbers that you should guess is one of them is negative 225, the other one is negative 400, and these two numbers will work. After this, we're going to use the zero product property, right? W squared minus 225 equals 0. W squared minus 400 equals 0. Solve them. W squared is 225. That means W is plus minus square root of 225, which is plus minus 15. Over here, W squared is 400. Take a square root, W is plus minus 20. And then since we know that the length cannot be negative, so basically means that your W has to be positive. So we don't need the plus minus. It's just going to be positive 15. Same thing with the other one, it just has to be 20. And then we're going to look for L. So remember, L is, using equation 3, 300 divided by W. So L is 300 divided by 15, and that's 20 for the first one. Second one, L is 300 divided by 20, which is 15. And remember, at the beginning, we assumed your length is greater than width. So you could say at the end, we could say that your length is 20 inches, and then your width is 15 inches. The other solution is the opposite. You just switch the order, saying that the length is 15, the width is 20, but it's more likely that we're going to have a widescreen TV instead. All right, so that will be this handout. Thanks for watching.